In this video, we will talk about using sigma notation to represent a series. Exploring sigma notation. A series can be represented in a compact form called summation or sigma notation. The Greek capital letter is a simple way to write the sum of a series. The given summation below means and is read as the sum of a sub I as I goes from 1 to n. So this is the upper bound. And this is the lower bound. And this one is called as sum, and this is the expanded form. Writing a series using sigma notation. For example, number 1, use sigma notation to the series. So the given here is a series since each term is separated by plus sign. And as we observe, there is a common difference d, which is equal to 3. So to find common difference d, so let's subtract a previous number from a term or number. So let's say 25 minus 22, which is equal to 3, or 28 minus 25 is also equal to 3. So our common difference here is 3. So if a series has a common difference, so therefore it is an example of arithmetic series. And if you could remember, our formula a sub n is equal to a sub 1 plus n minus 1 times d. So we have here our first term, which is equal to 13, and common difference d, which is equal to 3. So let's substitute our values. So a sub 1 is 13 plus n minus 1 times 3. So let's simplify this equation. So a sub n is equal to 13 plus 3 times n, so 3n minus 3. So a sub n is equal to 13 minus 3 is 10. 3n plus 10. So the n here will tell us how many times we will add 3 to 10 to gain a certain number a sub n. For example, if we want 31, so how many times we will add 3 to 10 to gain 31? So let's transpose this 10 to the left. 31 minus 10 is equal to 3n. 21 is equal to 3n. So let's divide both sides by 3. So 21 over 3 is 7. So our n here is 7. So we will add 3 by 7 times to 10 to gain 31. And 31 is the 7th term. So 1, 2, 3, 4, 5, 6, 7. So we're gonna use this equation to represent this series in sigma notation. So sigma notation, so 3n plus 10. So we'll change n to I, where I is equal to from 1 to n, which is 7. Since we have 7 terms here in this series. So if I is equal to 1, so 3 times 1 is 3, plus 10 is equal to 13. And if I is equal to 2, 2 times 3 is 6, plus 10, which is 16. And if I is 3, so 3 times 3 is 9, plus 10 is equal to 19, all the way up to 7. So if I is 7, so 3 times 7 is 21, plus 10 is also equal to 31. We can also write it as summation of 3i plus 13, where I is equal to 0, from 0 to 6. So our range still 7 terms, 0 to 6, 0, 1, 2, 3, 4, 5, 6, so still 7 terms. So we will just add 3 to the constant 10. So 10 plus 3 is 13, or just use our first term, which is 13. So if I is equal to 0, so 3 times 0 is 0 plus 13. Still, first term is 13. If I is equal to 1, so 3 times 1 is 3 plus 13 is equal to 16. If I is equal to 4. So 3 times 4 is 12 plus 13 is 25. And our last term, if I is 6, so 3 times 6 is equal to 18 plus 13 is 31. Always remember summation may have more than one answer. It can also be written as summation 3i plus 7. So we will adjust our range. Our lower bound will become 2 and our upper bound will become 8. From 2 to 8, still 7 terms. Our range will become 2 to 8. So if I is equal to 2, so 3 times 2 is 6 plus 7, still 13. So if I is equal to 8, so 3 times 8 is 24 plus 7, still equal to 31. So our last term is still equal to 31. And it can also be written as summation 3i plus 4. So our lower bound will become I is equal to 3 and our upper bound will become 9. So our range will become 3 to 9. We will just adjust our range from 3 to 9. So if I is equal to 3, so 3 times 3 is 9 plus 4 is still equal to 13. And if I is equal to 9, so 3 times 9 is 27 plus 4 is still equal to 31.
For example number 2, use sigma notation to the series 1 plus 3 plus 5 plus 7 plus 9 up to 2n minus 1. Again, using our formula, a sub n is equal to a sub 1 plus n minus 1 times d. So as we observed, there is a common difference which is equal to 2. So 3 minus 1 is 2, or 5 minus 3 is 2, or 9 minus 7 is also equal to 2. So we will substitute a sub 1, which is 1, times n minus 1 times our common difference is equal to 2. A sub 1 is equal to, so let's put plus sign here. So 1 plus 2n minus 2. So a sub n is equal to 2n minus 1. So we will use this equation to our sigma notation. In our sigma notation, so we'll change n to I, 2n or 2i minus 1. Our range will become from 1 to up to infinity, since we don't have any specific number of terms or specified number of terms. So if I is equal to 1, so 2 times 1 minus 1 is equal to 1. Or if I is equal to 2, so 2 times 2 is 4 minus 1 is 3. And if I is equal to 3, so 2 times 3 is 6 minus 1 is 5. It can also be written as summation of 2i minus 3 from I is equal to 2 up to infinity. So if I is equal to 2, so 2 times 2 is 4 minus 3, which is also equal to 1. If I is equal to 3, so 2 times 3 is 6 minus 3 is also equal to 3. If I is equal to 4, so 2 times 4 is 8 minus 3, which is also equal to 5. So I up to infinity.
For example number 3, use sigma notation to the series. So by observation, we get the common ratio by dividing a number by previous number or term. So let's say negative or positive 3 over 2 divided by negative 1, which is equal to negative 3 over 2. So our common ratio here is negative 3 over 2. So another 9 over 4 divided by positive 3 over 2. So this will become 9 over 4 times 2 over 3. Will become negative 18 over 12. So let's simplify. So negative 3 over 2. Just same with this. And using our formula for geometric series or sequence, a sub n is equal to a sub 1 plus or times r raised to n minus 1. Our first term here is 2 over 3, and our common ratio, negative 3 over 2 raised to n minus 1. And we're going to use this equation to our sigma notation. So 2 over 3, summation of 2 over 3 times negative 3 over 2. And again, we will change n to I minus 1. And for our lower bound, I is equal to 1 up to n is equal to 6, since we have 6 terms here. So if I is equal to 1, so 1 minus 1, it will become 0. So negative 3 over 2 raised to 0 is equal to 1. So 1 times 2 over 3. So our first term here is 2 over 3, which is the same as this. For example, number 4, use sigma notation to the series 3 plus 10 plus 17 plus 24 plus 31. So the given is an arithmetic series with common difference of 7. Since 10 minus 3 is equal to 7, or 17 minus 10 is equal to 7. And again, using the formula a sub n is equal to a sub 1 plus n minus 1 times d. A sub 1 is 3 plus n minus 1 times d, which is 7. A sub n is equal to 3 plus 7n minus 7. A sub n is equal to 7n minus 4. And again, we will use this to represent the series in sigma notation. So summation of 7n minus 4 as I goes from 1 to 5. Since there are 5 terms here, 1, 2, 3, 4, 5. So if I is equal to 1, so 7 times 1 is 7 minus 4, which is equal to 3. If I is equal to 5, so 7 times 5 is 35 minus 4, which is equal to 31. So this is the representation of series in sigma notation. For example, number 5, in this series, by observation, each denominator has a base of 2 with exponents from 0 to 7. 1, 2, 3, 4, 5, 6, 7. So to represent this in sigma notation, so it will become 1 over 2 raised to n, where I ranges from 0 to 7. So if I is equal to 0, so 1 over 2 raised to 0 is 1 over 1, which is also equal to 1. So if I is equal to 1, so 1 over 2 raised to 1, so 1 half. And then if I is equal to 2 raised to 2, so it will become 1 over 4. So same up to 7th term. So this is how we represent this series.
For example, number 6, writing sigma notation in expanded form. Write the summation notation I squared plus 1 as I goes from 1 to 4 in expanded form. So let's write first the given. Summation of I squared plus 1 as I goes from 1 to 4. First I is equal to 1. So 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1, and lastly 4 squared plus 1. So this is the expanded form.
For example, number 7, write the summation notation. Summation of I squared times x raised to I as I goes from 2 to 4 in expanded form. So let's rewrite the given. So summation of I squared times x raised to I as I goes to 2 from 2 to 4. Let's write it in expanded form. So first, I is equal to 2. 2 squared times x raised to 2 plus, second is 3. I is equal to 3 squared times x raised to 3 plus the last, which is 4 squared times x raised to 4. If you can notice, there are only 3 terms here since I ranges from 2 to 4. So 2, 3, and 4. There are only 3 terms here. So let's simplify. 2 squared is 4, x squared plus 3 squared is 9, x cubed plus 16, x raised to 4. This is the expanded form.